This video will give the solution to problem 60 in chapter 26. Now the problem asks, given this system, find the charges of the two balls. We know the mass of both balls is 3 grams. We know the length of the ropes is 1 meter. And we know the angles that separate them is 20 degrees. From here, we can start solving the problem. First, I'm going to isolate one ball and focus on it throughout the equation. I've arbitrarily chosen number 2. Since they have the same situation, we can assume that Q1 is going to equal Q2. After isolating one ball, I'm going to draw a free body diagram for it. So the forces acting on this ball is force gravity in the negative y direction, force Coulomb from the force of 1 acting on 2, and force tension from the rope pulling it up and to the left. Now I will break the force tension into components, and then I'm going to solve for the sum of the forces in both the x and y directions. So this force tension has a y component and an x component. The y is in the positive direction, and the x is in the negative direction. From here, I can use basic trig to solve for the components. Now, using this triangle, that's what this triangle is. We know that this angle is 20 degrees, and so using basic trig, we can solve for each of these components. So I'm going to solve for force tension x first, which would be sine of 20 equals force tension x over force tension. Now, force tension in the y direction is going to be cosine of 20 equals force tension in the y over force tension. From here, I can continue solving the problem. So next I'm going to set up the two equations for the sum of the forces. So we have sum of the forces in the x direction will equal negative force tension x and positive force Coulomb. For sum of the forces in the y, we will have negative force gravity plus positive force T in the y. Now I'm going to solve for the y's first because I know more about it, but also what I know is that the situation is in static equilibrium, so the sum of the forces has to equal 0 for both of them. Now solving for y, we have 0 equals negative force gravity plus force tension in the y. Just simply plugging in what we know, we have negative mg plus force tension times cosine of 20. Again, when we look at this, there might look like we have 3 unknowns. However, there's only one we don't know about, and that's force tension. Because we know the mass is 3 grams, and we know gravity is 9.8 meters per second squared. So again, remembering that this is in grams, but it needs to be in kilograms, we have 0.003 kilograms times 9.8 meters per second squared plus force tension times the cosine of 20. We can just use algebra to solve for force tension, and when you do, you get 0.0313 newtons. Now I need to remember this, so I'm just going to write it up here because it'll help me when solving for the sum of the forces in the x direction. So now I'm going to go to this one. So sum of the forces in the x. 0 equals negative Ft in the x plus Fc. So Ft in the x direction is just going to be negative Ft times sine of 20. So for force Coulomb, we know what it is. We can substitute it with just Coulomb's law. And since we've already established that Q1 is equal to Q2, we only have one unknown variable. Also, what we need to find is the radius, though. So this radius right here, using, again, basic trig, using the angles that we know, we find that r is equal to 0.68 meters. So k times q squared over r squared is what we plug in for force Coulomb. So as we go through, we get negative 0.0313 newtons times the sine of 20 plus 9 times 10 to the 9th times q squared divided by 0.68 meters squared. Now, solving for q, we get 7.49 times 10 to the negative 7th coulombs. After looking at this, we know that we only have two significant figures. So it's going to be 0.75 microcoulombs because we have a negative 7th, which turns out to be micro. So Q is equal to 0.75 microcoulombs.